So I'm sure that some of you have definitely seen that viral video known as universe size comparison. And I also know that some of you definitely thought the sun was the biggest star in the universe until you watch the rest of the video. So in today's video, I'm going to be telling you everything that you need to know about stars. Also, I'm not going to ask you to like and subscribe because I feel like that is begging for subscribers. So if you agree with me on that, make sure to like and subscribe. And let's get right into it. So I'm sure some of you know what a star is. Big ball of fire that burns in space, right? Wrong. You see, despite the popular belief, stars aren't made of fire. Stars are actually burning balls of plasma that is held together by self-gravity. Stars form deep within a nebula, and deep within a nebula, gravity gets closer together, and closer together, and closer until it's a star! Oh, and a nebula is just ionized stardust, by the way. This right here is a real picture of a protostar, or baby star, taken by the most powerful telescope ever built, the James Webb Space Telescope. You can even see the protoplanetary disk around it, and even a jet shooting out of it. That is literally us, 4.6 billion years ago. There are 5 main types of stars: dwarfs, main sequence, which is what our sun is, giants, supergiants, and the most massive, hypergiants. Oh, and if the star formation fails, it turns into a brown dwarf, which is basically more of a planet than a real star. These stars can fuse fuel known as deuterium, which is basically hydrogen but heavier. However, they can't sustain it, and they just wanders through the galaxy as a failure. You might have heard Jupiter was a failed star. Jupiter needs to be literally 13 times more massive to even become a brown dwarf, and 80 times heavier to become a star. However, Jupiter still is so massive that both the Sun and Jupiter orbit each other. Red dwarfs are the slowest burning stars and also the most common type of star in the universe. Not only are they common, but they are the longest living stars ever, capable of living up to, I am not kidding, 10 trillion years. As the red dwarf dies over trillions of years, it slowly increases in temperature, and it becomes a brighter and hotter, hypothetical, blue dwarf. Yeah, these stars live for so long we aren't even entirely sure how they die. Over quadrillions of years, the blue dwarf slowly fades into a dead black dwarf. These things barely emit any radiation, and will just continue to sit there and either get sucked into a black hole or just eventually decay away. Main sequence stars, on the other hand, have a more epic life cycle. As the star is born, it slowly expands over billions of years. As our sun, for example, it increased into a yellow dwarf main sequence. Oh, just know, yellow dwarfs are actually larger than 80% of the stars in the universe. However, they certainly are not the largest. Aww. Our sun is only about halfway through its life cycle, but it's 4.6 billion years old.
We got a boomer!
Over time, the main sequence will slowly expand into a giant. When the sun expands in 5 billion years, it'll engulf Mercury, Venus, and if we're unlucky, possibly Earth. 5 billion years after that, it will shed its outer layers, leaving behind its exposed core, which is known as a white dwarf. Over time, the white dwarf will fade into a black dwarf, and once again, will either get sucked into a black hole or just decay away. Supergiant life cycles are even more exciting. These stars start off in the main sequence, but are way more massive. As it ages, it gets larger and larger, and at its peak can be up to 5 billion times larger than the sun. Anyways, after around 10 million years or so, the star completely runs out of nuclear fuel, the core turns into iron, and the star begins to die.
I'm dying!
The iron will have made the core so dense that the star collapses into itself and then basically just self-detonates. This explosion is known as a supernova, and it leaves behind a supernova remnant and a neutron star, or if it's massive enough, a black hole. Lastly, we got the hypergiants. They basically live the same life cycle as a supergiant where they collapse and explode. However, they don't explode into a supernova. They explode into something that is like one of the coolest names ever, known as a hypernova. Supergiants usually become neutron stars, and hypergiants usually become black holes. Neutron stars are the leftover cores of supergiant stars. They are only about 20 kilometers across, but can weigh as much as the sun. One glass of neutron star material would weigh as much as 16,000 pyramids of Giza. Oh, and how could I forget? These things spin absurdly fast. I'm talking 100 rotations per second fast, with the fastest being named this thing, spinning at 716 times per second. Oh, and one more thing, these things are so dang dense that just like a black hole, they warp the space behind them. Also, when hypergiants die, they tend to do something known as a gamma ray burst, which is the brightest thing in the universe, shining at over a quadrillion times brighter than the sun. One gamma ray burst in 2008 was located in a galaxy 7 billion light years away, and it was so bright you could see it with the naked eye for 40 seconds. There was also this gamma ray burst called GRB 22109A. It was way brighter than the previous one I was talking about, with this one being 1 quintillion times brighter than the sun. And even though this one was much closer at being 2 billion light years away, you actually could not see it with the naked eye. Wanna know why? Well, it was covered up by interstellar dust. Fun fact, this picture of a star, Stephenson 218, is the biggest star ever discovered. It is a red hypergiant that is 10 billion times bigger than the sun. It is so big, in fact, that 13 quadrillion Earths can fit inside of it. Also, back to supernovae, I want to give a list of the coolest supernova names that could have possibly been given. Starting with the Crab Nebula, and then we got the Witch Head Nebula, and then we got... Alright, back to gamma ray bursts. So, I just want to point something out. How do you even notice this? I mean, look at this. Doesn't even look like a gamma ray burst. It just looks like interstellar dust part of the galaxy. Oh, but that's not even the best part. You see, this isn't even the full image. This is a zoomed in photo of a James Webb Space Telescope image. You want to see the full image that they somehow managed to notice this in?
Enrique!
At this point, I am fully convinced that NASA engineers are straight up more unemployed than Reddit moderators. To the person that found this, hats off to you. What could you have possibly done to notice that image? I mean, it has to be something like this. Yo, bro, what you doing? Oh, nothing. I'm just looking for gamma ray bursts. Oh my gosh, I found one. Really? Can I see it? Yeah, sure. There it is. What is wrong with you?